Right. Hey guys, welcome back to AI with MJ. As you all know, I'm solving NeetCode 250 questions, and this is problem number 4 from that list. I will be covering the brute force solution, the optimization, and dry run for this particular problem, also along with two variants. The first variant being what if the input was sorted, and the second one being the dominoes as pairs. All right, so once I paste that question, I'm going to set a timer for 20 minutes, and the goal is to complete it in 20 minutes. Okay, so the question is, let me set the timer. Okay, so we are given an integer's nums and an integer's target. Return indices of the two numbers such that they add up to target. You may assume that each input would exactly have one solution, and you may not use the same element twice. You can return the answer in any order. Okay, so here the input is an array of integers, and we have to return also a list of integers, the indices. Okay, a few questions would be array always empty array, the array as input. Second one would be of one element in the input. Um, is it just numeric characters like integer, float, and size of nums, like how big the array would be, and target, is that int or float, and how big can the target be? Um, Other question would be positive or negative numbers. Okay, so in this, we can assume if it is an empty array, just return an empty list. And if only one element, then we will also return on an empty list. Because if the target equals the number in the list, otherwise, just an empty list. For this situation, it's just integers. Um, we can assume no negative. Size of nums could be from 0 to, let's say, 10 to the power of 4, and target could be from 0 to, again, um, 10 to the power of 9. Oh, this was it, and then target is integer for this situation. Okay, so what if nums is this? Then the way that we can solve this problem is maybe using a for loop. So for example, if our I pointer is here, that is for loop, and then we can start another for loop from this J pointer, and we'll check does these two add up together to give the target. If yes, then just return if I equals J, return target. Or otherwise, if suppose let's say target was 17 here, then we will keep moving j till end it. And let's say if we had 15 plus 7, that's um 22, right? If the target was 22, then we finish that loop for j, and then we will move our I pointer for the rest of the elements, and j will start from 1 beyond the I. The time complexity here would be, here we return indices O of n square, because we are looping the array 2 times, and space would be constant because we are not using any additional space. One optimization can be, we can like just store the value, right? So if we are looking for target equals, let's say 17, and we are at index 2, then we know that 17 minus 2 is equal to 15. And if 15 is already been is in like a scene, then we just return the index. So here the time complexity will be O of n, because we are only doing one pass solution, and any lookup from um, hash map would potentially be O of 1, O of n actually. I need to confirm O of n to go over the loop, plus like let's say we check hash map n times, then to check the hash map, and space would be O of n to store all the numbers. Worst case scenario. Yeah, so I think that would be it. Let's say my interviewer agrees that can just implement the solution. So we could do define to sum, and the input here is nums, which is a list of integers, and target, which is an integer. So this would be target minus current number. And from typing, we import list. Okay, and the output is list of integers. Okay, so for we need the index of the number, and we also need the number in enumerate nums. This function helps to give us the index, and do we need a hash map. So hash map is equal to default dict. So we don't have to deal with any missing keys, and default dict would be integers as well. So we add in hash map the current number. Hash map at number is equal to that index. So the hash map would look something like this. So it will be 2 at index 0, 7 at index 1. And now we're going to check if that number in hash map, then actually we'll have to check the complement. So which would be target minus current number. So we'll check if complement is in hash map, then we'll return the current index and its complement. So that is hash map of complement, and this will give us the other index. And then as such, we're not returning anything. I can just put an empty return statement. Okay, let's do the dry run quickly. We can just use this. Oh, as mentioned, the base cases. So if len of num equals 0, we return an empty string. And if len of numbers equals 1, we return empty string if num number is like number at index 0 is not equal to target. Else we return the number at index 0. Yep. Mm, I think this should be all. Let's do a dry run quickly. I can just use a different example. Let's say we have nums is equal to 5, 7, 8, 2, 4, 5. Um, so target is, let's do 15, and answer is B 1 and 2. And also I forgot to ask, like, here for the question, um 1, actually it does explicitly say that there is only one solution, so that's fine. Okay, so that's the answer. And let's say this is our number, and we have index and number, and this is our dictionary hash map. Hash map is equal to this. So we come to line number this, that's not true, that is not true, so we'll move here. Now we are at complement. So here the complement is equal to 15 minus 5, which is 10. So is 10 in the hash map? It'll check that. No. So it'll just add the current number, that is 5, in the hash map with its current index. That is this. And then it moves back up to when I is equal to 1 and number is 7. And now we'll check for 15 minus 7, which is 8. It'll check if 8 is in the hash map. No, so it'll just add 7 to index 1. And then we move on to 8. Now when we do 15 minus 8, that is 7. And it'll check in the hash map that does it exist. Yes, it does here. So we will return the current index we are at, and then hash maps complement number, which was 7, and we are returning its index in the list format. And yeah, that will be the algorithm. And yeah, variants. Let's talk about variants. So the first one is, what if the input was sorted? So let's say our example is 2, 7, 11, and 15, and target is 9. So the output would be again 1 and 2. The same thing remains. But then we can do the same thing again. Time-wise, it would be O of n, and space-wise, also it will be O of n. But here the interview will be like, is there an, can you optimize the solution? Nice. It. Yes, we can because the input is sorted. Most of the time when the input is sorted, we can do like binary search to check. So what we can do here is, let's say we are doing binary search. So our left pointer would be here and our right pointer would be here. And okay, wait, hold on. This is our right pointer. So our mid would be at index 1 because that's how it'll round up. And we will check if like complement, sorry, if target minus mid. Yeah, like if we'll have to check if the current sum. So we have to check current sum, which will be left plus right. And then we check if, so right now current sum is 17, which is way bigger than our target. So we will have to move this right pointer towards left because obviously the to decrease the current sum, we will have to decrease the number. So when we do that, our left remains same, and then our mid pointer would already be at 7. Now it is again 11 and 2, which is still bigger, so we move our right pointer here, and then mid becomes here. Now when we check, they are equal, and that would be our base case. That once they are equal, we just return. In this scenario, a solution always exists. And let's quickly code it up. Again, define two sorted, and our nums input will be list of integers and target will be integer when we will return a list of integers. And as mentioned, we'll have a left pointer, right pointer, which will be at 0 and len of index, len of nums, and that will be at the last index. And then we will do while left is less than right. We can't do equal to because we have to find the current sum. So the current sum equals target. No, it's nums at, oh my gosh, number at index left plus number at index right. And also I realized that we don't really need the midpointer. Like basically the current sum is the midpoint. Like if suppose current sum is that, then we can just decrement it. So it's not exactly binary search, but it should work. Yeah, and this would be log of n solution, I think, but I can confirm. Your time would be log n. Because, or maybe not. We are still checking at every index, right? Mm, let me check. Nums at no, this is not log n. This one that I just mentioned would be an log n. So I think like if we are doing a log n solution, oh, my timer is up, but I'm gonna keep going because there is one more variant that is left for this question. Um, so we can maybe compare the mid with the complement. So how will that work? I'm not sure. I'm not gonna take more time. There is like overall it could be an inner binary search, but we still have to do it. So I think we don't. It's a O of n solution and not log n. Yeah, well, that is the current sum. It becomes more of a two-pointer solution. Yeah, so if current sum, that's the base case, is equal to target, then we return left and right because those are the indices. Else if, let's say current sum is bigger than target, then we will move this pointer backwards. So it'll be right minus equals 1. Else if current sum is less than target, then we'll shift the left pointer by 1. Yeah, otherwise we just return an empty string. This case would never exist because we have promised to have like a solution already given to us. Okay, let's do the third variant. Variant 3, Domino's pair. Domino pair. This is a very famous meta variant. So the question is, let me paste it quickly. Okay, so let's put this in here, go to the top, and that is the initial part of it. And the example would be this. Okay, so we you are given an array dominoes where each element is a pair of digits x and y, representing a domino tile. You're given an integer target. Return the number of unique domino pairs A1 and B1 such that A1 plus B1. Okay, and that is also okay. So here the output is 2. Okay, let's see why. So 3 plus 1, 4. So it's not equal to target, so we can move on. Then I think only 1 plus 9 would be the solution, and then since there are two of them, that's why it's equal to 2. Same approach applies, right? So let's say we are at, hold on. So if we are at Domino's I, we can have like a hash map with this variant. So suppose 3 and 4 is at index 0. And then what we can do is we can convert this into 34, like a digit, rather than like doing a tuple and then all that. Then we'll check for 19, which is at index 1. Then again 34. So for this, we will have to check for 9 minus 3, which is equal to 6, and 4, 9 minus 4, which is equal to 5. So 65. Is that exist? No. And for this one, it will be 91 because 9 minus 1, sorry, 9, yeah, 10 minus 1, 9. And this should be 10 actually, 10 minus 3. And 10 minus 4, which is 7 and 6. And so on. So right now it does not exist, so we can just move on. And we just have to count the indexes, like how many pairs actually exist. So we can make it 2 here when we come to this position. So let's say right now we are at 19 and it's only 1. So it's the frequency, digit and the frequency. Digit is to frequency. And then we do 19 and then we move our index to 3, 4. So we're looking for 10 minus 3, 7. And 10 minus 4, 6. Does not exist. That's 1. Now we are at 2, 1. So 10 minus 2, 8. And 10 minus 1, 9. Again, does not exist. Now we can have like an answer variable, which is at 0. And for this one, we're looking for 19. 19 already exists, so we add that and we decrement this by 0. So by 1, so we don't overcount the same one. And then we move forward 91. Oh, and also add that, right? Because that is 1. And then we are at 91 again. But 19 is 0, so we move on. And 91, this 91 we will add. Then we are at 76. And actually, we're looking for 19, right, for this one. Oh no. Yeah, and then we are at 76. So we're gonna look for, we have 276, but the counter would be 10, 30, 10 and 34. 34 is not there. It's only, maybe it should be one more, right? So maybe 2. We add that and then we continue. And then we will, yeah, so I think there were 3 pairs, 7 plus 3, 10, and 6 plus 4, 10. And then 9 plus 1, 10, and 1 plus 9, 10. So this should be 3, not 2. I think the answer here should be 3. So 1991 and 9119 and 3476. Let me just check this quickly. I think it's this. So I guess this 91 is being counted as duplicate. That's why the answer is 2. Okay, makes sense. Yeah, I can go ahead and code it up. So define domino sum, and we are given dominoes, which is a of list of integers, and a target, which is given in integer format, and we have to return an integer. And we need like a frequency mapper, which would be this, and unique pairs we can do so that we don't recount it. So scene or set, and this would be unique pairs, and we do for x, y in dominoes, and complement here would be target minus x, comma target minus y. You could just, and if complement, I mean, this is the tuple method though. We can do digit one as well. Give me 1 second. I'm not sure about the code. Okay. So instead of doing that, what we will have to do here is complement of x is equal to target minus x, and complement of y would be target minus y. Okay. And they've mentioned that digits will be from 0 to 9. So how we can convert is comp val will be 10 into complement of x plus complement of y. Yeah, because for example, if we are at 34, so 3 and 4 was the thing, right? So it will be 3 into 10 plus 4. So that will be 34. And then if comp val in frequency, yeah, then we append answer plus equals 1. I mean, I guess we could just return like a unique pair. Um, I think this would be just unique pairs dot add pair. And for the pair, we'll have to sort it so that it's not the same one. And if it was not unique, then what we do is we don't need this. If it's there, answer plus equals 1, and we'll decrease the frequency of minus equals 1. And or if that is not the case, then we will just add frequency in comp val plus equals 1. And for this, let's just use default baked to avoid e value. And answer would be initialized to 0, and at the end, we just return answer. I don't have enough time to do the dry run for this, but this is a common interview variant. I'll be ending the video here, but if you do have any comments, let me know. And if you think I know I could have done better, but yeah, thank you for watching.